Okay, so thank you. That's Lewis for that reminder. So again, let's confirm, is the document displaying on your end? I'm going to zoom it in a short while, but is it showing on your end? Just to be aware what things are on your end. Let me have a text there. Yes, it's showing. Thank you. Thank you. That's several of you confirming. Thank you, George, Wanyiri, Dennis, and Nasike there. Thank you. So we're going to let me try to zoom it a bit. Now, sorry, these documents are still not yet at your portal, but I mean at the portal, but in just immediately we'll be ending this class. I will post them there. As I've just mentioned, it means that we're looking at probably two documents, because this one, the one which is showing, it's talking about the database lifecycle. I don't intend to use a lot of time here, and of course I'll explain the reason. The database lifecycle. All right. So the database lifecycle. Now, this says that relational database systems underpin the majority of the managed data storage in computer systems. This course presents an overview of the development lifecycle for a database system and highlights how the database development differs from traditional software development. This should not be this course, should be this topic here. Essentially, is this topic. All right. So, introduction. Of course, now the reason, as I said, I will not take much time, is that although it says that it will highlight the differences, or to show how database development may differ from traditional software development, but you'll find that a lot of the issues are the same, because in what we call the system development life cycle, or development, sometimes we call it software development life cycle. We also use the popular acronym, just the acronym is Sdlc. Now, those it's the same. This is the database case. You may not have all the. Of course, there are certain differences in the concept, but a lot of the issues are the same. It's about the process of doing a project. The project has to do with the software. So when we are doing a software project, then we normally follow what we call the Sdlc. Now, there are a lot of issues that are similar when you say, Sdlc, or now we are talking about database lifecycle. There are a lot of similarities, but yes, there are also some differences. Now, because of the similarities, that's why I don't think we need to take too much time looking at the issues that are raised here. But of course, I'll highlight a few things. As it says, of course, there are some differences. What are some of the issues that we find? Now, when we look at an ordinary Sdlc, an ordinary Sdlc would look something like what is showing in the diagram here, which I'm trying to display. So this diagram is a usual Sdlc physics based on the waterfall model. I'm sure you are recalling that. The waterfall model would follow something similar to what is in the diagram here. If you focus on the parts that are not in the box, I think that's where you can see it more clearly. The parts, the text that is not in the box, you see, number one at the top, establishing requirements, then analysis. And of course, now normally in a waterfall model, the top we call it user requirements or requirements gathering or something like that. So establishing requirements, and you go to analysis, then you go to design, then you go to implementation, and then finally, now that's where there is a difference, of course. Sorry, this one now is showing the SD, the one for the database actually. Okay, so in Sdlc, normally after design, you should come to testing. All right, you normally should come to testing, but this one seems to be going the other way around. So design would go to testing and then implementation. But this one, testing is coming after the implementation, and that's why, of course, we say there is certainly some difference. And of course, we'll say why that is the case. So this one is actually more based on the database life cycle. But it's very important, because actually this is meant to be the waterfall model. For some reason, I don't know why it is not showing because during the design, oh yes, of course, there is the actual development after the design. There's, of course, we talk about development, which is the implementation. So, but in this case, with the usual Sdlc, the implementation here is testing maybe the code and things like that. And finally, of course, we do the implementation, which is now building the system as it should be when somebody is working there. And then, of course, we do the final testing, of course. So this is more about, so normally in the Sdlc, we talk about design, then we go to testing, because it's mainly, we focus on the code. That time we are talking about the code. But once you implement the system, of course, you still need to test it. You implement, you test it, and then finally there is maintenance which continues after the implementation. All right. So that's a comparison between the usual Sdlc and the what we are calling now the database lifecycle. The issues are very much similar. Now this one, as I said, is actually, this diagram is meant for the waterfall model, which is Sdlc, one of the models in Sdlc. And so when we go to the database, there will be very little difference if you look at it, except for some parts are named differently. It's very much similar. So because this now is what we would call the database lifecycle. So with the database lifecycle concept, again, it's the same issue. It's about developing a software. Only that, of course, with the databases, we don't go right to the very basics of coding and all that. Of course, what we have is we get a system. We get a database, what we call now the DBMS, database management system, which is already a complete system. The only thing that now we are doing is looking now at the data. The database, all this discussion is more about the data in the database. How do you get your data into the database? What do you need to do so that once your data is in the database, then you have an efficient system. You can, that database can help people. It can help people in terms of their needs. All right, in terms of their needs. So how do we deal with that? So already we have a software, a DBMS. So how do we now go about using that DBMS to come up with a database? Because a database, of course, is not the software per se. The database is the data. We are storing some data. We want to have a store for data, but beyond just the data, how do we make sure that we can access this data for the needs, the reason why we are creating it? And that's where the whole concept of database lifecycle comes in. Just a minute. All right, getting to the database lifecycle, therefore, you notice that there is a lot of similarities. And so I will probably just highlight a few issues now in the whole concept of the database lifecycle without necessarily looking at it so in a so much a detailed manner, because you notice that actually some of these there are issues that many concepts are repeated. They are repeated. When you look at the two, in parallel, the Sdlc versus the database lifecycle, they are very much similar in many ways. And so I will just highlight when it comes to the database lifecycle, therefore, what are some of the things that we need to consider. All right, well, I'm still going up a bit back to the document parts where we did the introduction. And here, let me just highlight the concept written here, desirable properties of a database. Some of the key desirable properties of a database are outlined in this table below here. So we need the database when we design it. We want to have what we call completeness. And see that this ensures that users can access the data they want. There's a note that this includes ad hoc queries, which would not be explicitly given as part of a statement of data requirements. Integrity, it says, ensures that data is both consistent and correct. And of course, it explains there that when we say consistent, we mean no contradictory data. When we say it should correct, we say it is no invalid data. Flexibility, it says, ensures that a database can evolve to satisfy changing user requirements, flexible to capture any developments that may come after it is already done. Efficiency ensures that the users do not have unduly long response times when accessing the data. And of course, usability. Usability is a concept that has to do with something to do with ease of use. It's easy for a new person to get here, follow how to work with this system. They may need to be trained initially, given some support, but at least they can catch up and quickly learn how to go about working with the system as quickly as possible. And so that's important for a database. Of course, it's important for any system, but probably for the database might even be more important. All right, so as I said, I don't intend to read the whole of this document. I'm just picking bits and pieces of the parts. Let me come here and say that database development is not just a matter of creating tables that seem to match the way you see data on forms or reports, but requires a detailed understanding of the meaning of data and their relationships to ensure that a database has the right properties. This understanding comes from data analysis, which is concerned with representing the meaning of data as a conceptual data model. With the database, the entity relationship modeling, the end result of that process is to give us a conceptual data model. But we'll say more about that in a short while. All right, so the database life cycle, it says the database development is just one part of the much wider field of software engineering. The process of developing and maintaining software. A core aspect of software engineering is a subdivision of the development process into a series of phases or steps, each of which focuses on one aspect of the development. The collection of these steps is sometimes referred to as a development life cycle. The software product moves through this life cycle, sometimes repeatedly as it is refined or redeveloped until it is finally retired from use. So ideally, each phase in life cycle can be checked for correctness before moving on to the next phase. And coming down here, database life cycle is just the usual system development life cycle, but focusing on database development. And so there is those diagrams that we had seen earlier. So these can jump this part now. And this is a brief explanation of the Sdlc phases. So that again, I will just skip, as I said, the same issues that you have worked on in what is called, this is normally taught in systems analysis and design. I want to believe that you have covered that area. So I will not take time there. And so let's pick again retro up here. I'm trying to get this one up. Not okay. Can keep it as it is anyway. All right, so database development life cycle phases, again, as I said, is very much similar to what we see in the Sdlc, and they are there. So we can now maybe take just a short moment to look at the phases again. So when you look at the phases as explained in the diagram here, we find from the top, we have establishing of requirements, and then we get, so of course, once we do that activity, then we get data requirements, and then we do the data analysis. So when we do the data analysis, then we create a conceptual data model, and this is where now entity relationship diagram comes in, or the data entity relationship modeling. Entity relationship modeling, actually, after you do when you do the entity relationship modeling, you end up with something called the entity relationship diagram. You create an entity relationship diagram. That is going to be a conceptual model of the data for the database. And then, of course, you move on, you go to the design phase. You do the database design. And after the database design, then you have what is called the logical schema. The logical schema. Actually, at the database design, we produce we do the design at two levels. One level is the what we call the logical design, and the other one is called the physical design. So we have logical design and physical design at this area here, where we have the database design. Once we do that, we are ready now to create our database, and that's what we are calling implementation. So we are ready to create our database at the computer. So we go to the computer and we start now creating our database. And notice that up to the logical schema, we have not yet gone to the computer. We are just designing. A lot of this actually is going to just be paperwork. A lot of these will be paperwork up to this point. But when we go to implementation, now we go to the computer and we start now creating our database at the computer. And so we create what we are calling here initial schema and a database. We create an initial schema and database. That is we are now actually right at the computer there. We are creating our database. And then, of course, we not only create database, but also add the data. We add, of course, initial data, add initial data to the database, put if it's for an educational institution, maybe put the names of the students into that database, the program they are doing, what semester they are in, and what units they have done so far, and what units are they doing this particular semester. Put it in the database, and of course, do now the test to see Of course, you don't put a lot of data initially. After doing just enough data to help you to do the testing, then you do the testing. Now here you are testing to see if the document, the database is running the way you had initially proposed. Is it being able to display your data? Is it being able to get the data? Is it able to get only what you need? For example, if you say you just want a list of students, is it able to bring just a list of students? If you want to say we want to see the names of the students as well as their where they have reached now, are they in year 1, SEM 1, are they in year 2, SEM 2? Can it show that? So you do the testing. So you do the testing and make any necessary corrections. And then, of course, finally, you say now the database, you have done all the testing, and now, yes, you can go ahead and use it. It is ready. And that's what he's saying. Release schema and database means that now the database, you have done the testing, everybody is satisfied, and so now they can start using the system now as the system for the institution. It's ready to be used. From there now is something called maintenance. So notice that this is also another phase. It's actually part of the phase. So after testing and the implementation, the release of the release of the system to the users, and then we go to the phase called maintenance. Now, maintenance, of course, it's an ongoing process, it's an ongoing activity that comes after the system is released to the owners of whoever you are developing this system for. Now it is released and it is going on. And so with that, that just explains the process, the stage by stage of database lifecycle. You can call it a database lifecycle. You can call it a database development lifecycle. Whichever is the case, is the same. But those issues are explained in more details down here as you move on. So there is a requirements gathering, which is the same concept as before. There isn't really anything really very, very unique about doing this for a database. But of course, database here, as I said, we are more focusing on the data. The data that is going to be stored in the database. Now, we're not saying about specific data, but we're saying how will we capture the various data items that we need. For example, yes, it is an educational institution database. We are saying, yes, we will be needing to be able to retrieve a list of the names of students. So that's where now the focus is. That list of students, how will you store it initially into the database? And how will the database retrieve the names when you need them? So that's what the focus is, storing a data item called name of student. And maybe in terms of a first name, middle name, surname. So we have to think about that. How will we store the data about a name? And will our system be able to display that list to us when we need it? So how first of all is the input, and then there is the output. So that's so these items may not also take much time, except where we need an emphasis now in terms of the database. So when it comes to the analysis phase, is that data analysis begins with a statement of data requirements and then produces a conceptual data model. So one of the main result of doing analysis when it comes to this case, the database, we produce a conceptual data model. Now, this conceptual data model will actually be described in form of what we call the entity relationship diagram. Entity relationship diagram, or ERD. Now we'll talk about that in a short while. So let's just keep moving some more issues expressed here about analyzing the data requirements. So we say analyze the data requirements, not the implementation. So it's about the data, just understanding the data and being able to describe it in very clear terms that would be possible to implement at the database. Then, of course, there is a design. So the design phase, the database design starts with a conceptual data model and produces a specification of a logical schema. All right. So again, when it comes to design, you find that actually design is like the conceptual data model is both an item of analysis, but it's also an item of the data, the design phase. The conceptual data model that we build seems to be in both phases, so to speak. But of course, it develops from the analysis. But it's part of the design to some extent. All right, so let's say I'm moving down here that the output of the design stage is a detailed relational specification, which is a logical schema of all the tables and constraints needed to satisfy the description of the data in the conceptual data model. So we build up from the conceptual data model, and then now we go to the design. And when we do the design, we develop the logical schema. Now this one is also it's actually an improved ERD. So the logical schema in most cases is also an improved ERD. But because you're dealing with most of the time, it is about now relational database management systems, then we also borrow from what we're calling the relational representation. So we have the relational representation. So now at the design, if we are using the relational database management systems, so we now be describing our design in two ways. One, we are going to use an improved ERD, and we show what improvement we are talking about, improved ERD, and you're also checking you're also using the concepts of the relational data modeling. So what does relational data modeling tell us about the design at this level, the local or logical schema? Okay, so the design phase, therefore, again, what we get there is an enhanced, maybe the better word is enhanced, an enhanced ERD. Then, of course, once you do the design, of course, you go to the implementation. So you construct. So implementation involves construction of a database according to the specification of a logical schema. So the logical schema is what you come up with after the design in the process. You develop now the logical schema. Now the logical schema should be very close to how the database will look like in terms of its structure within your when you actually start going to the computer and creating your database. So the logical schema. So you will then now go to the computer, construct the database. Go to the computer and now construct the database. That's what we are calling implementation. And of course, so you populate your database. So of course, that means add data now to the database. Of course, as we said, once you are doing all these, you're also testing and being sure that actually the database is behaving the way you like. So populate the database, that is, now put data into the database. And it says, of course, that can be done in 2 ways after the database is created. Once you are now ready to, you have implemented the database in terms of building up, and then now add the data. And that can be done in, how do you add the data? Either you can just add it, directly by just, it's maybe the first time that you are creating a a computerized system for your data, maybe in an educational institution, then you are going to just that you don't have any computer data somewhere. You are building it right from scratch. But sometimes you could have been having another system. You will just now transfer data to a new system. So we have all these approaches for populating our data, our database. All right, so just a minute. Okay, so some of the things that you do, therefore, the implementation is, of course, now install the software which has not been installed, then start putting the data, and then also you need now to start also deciding on how with the users be able now to access the data. You set them up, and other things that relate to the users. So, of course, the main thing is to create how they will access. Use of a database involves user process, which must be developed outside of the database development. In terms of the three schema architecture, we now need to address the development of the external schema. The user interface of the users will be using to access the database and do their work at the database. Then, of course, we need to support or do what we are calling supporting data management strategies. So how will, during the life of your database, some of the things that are key, one of them that is highlighted here is the issue of backups. And of course, the other issues that relate to what we're calling supporting data management strategies. So once you have your data, of course, you don't wait until all your data is in. Of course, you do the testing. After you put that sufficient amount of data before you do the testing. Of course, we are not saying that you do testing after you have added all your data. No, of course, you have to test your system. After putting some good amount of data that is sufficient for testing, you do the testing. Test your system, make sure that it is doing the right things. So, for example, can it prevent somebody that is not authorized not to access that system? You have to test that actually it is being able to prevent unauthorized persons not to be able to access the database. So you do the testing. Of course, the testing has many other issues. Of course, even the data itself, you want to test whether it is being able to enter the data as the way you have designed it, as well as retrieve the same data. Many issues, of course, come up at the testing. And this was critical here to just understand about the process of testing, validation, and verification. So when we do testing, we always concern ourselves with these two words. We do validation tests, and we also do verification test. These words again should have come up somewhere in some of your units that relate to software engineering. So it's actually there is software engineering, the system analysis and design, but especially these words should come at software engineering. So it tells us when you do the validation test, it says validation answers the question, has the right database been developed to meet the user requirements? Now, of course, we talk about a right database in terms of the requirements. What were the requirements? What did we say at the point of requirements? What did the user say? What type of data do they want this database to capture? So we measure, we do the testing validation test. It's supposed to measure whether our database is actually a reflection of what the user said as the requirements of his database. Then there is a verification. So this one is the question, has the right design been implemented correctly? Has the database design been implemented correctly? The other way of asking that, normally software engineering say, have we done it right? Have we done it right? Validation, have we done the right thing? Now, those are two different concepts. Have we done the right thing? Then the other one is, have we done it right? So we can do the right thing. Now, normally it goes the other way around. If you don't do it, right, the possibility is very high that you not have the right thing. But anyway, those two are very much they are almost part of the same thing. It's like what we say, they are two sides of the same coin. So you cannot really separate them, but we have to ask each of them specifically at each point. Have we done so validation? Have we done the right thing? So that is a measure of the requirement. And then we have we done it right? Did we follow the standards of developing a database? And also making sure that every detail about the expectation of how the database should run, have we taken care of all those particular issues? Very important. All right, so that's testing. And of course, we get the phase of the maintenance, which is simply now the database is already in use, but there are always some things they do develop and they need to be taken care of. Since the databases are one of the more enduring software engineering artifacts, it is not uncommon to find database implementations whose use can be traced back for 15 years. So a database, of course, can stay for many years as the same database that is being used by an organization. So the operational maintenance issues are, of course, there are a few things enhancing its capacity in terms of what we call the versions. We improve it, have it a new version. There is the issue of porting. So there is a porting implementation maintenance. The databases, the user processes, the underlying computer system, or some other aspect that goes changes that require the database implementation to be revised, porting. There is a requirement change. Some issues arise up that need to be added to the system. So maintenance can mean quite a number of things, but it's very, very important. It's a part of the life cycle of the database. So for the database life cycle, I think that's sufficient to talk about the database life cycle. And as I said, a lot of things are very similar to, except of course there are some unique issues when it comes to database, but the phases are very similar. But it's also very important that you capture the unique issues relating to the database when you talk about database life cycle. But for this particular topic, I think that is sufficient. I want us to move to the other topic and quickly also run through it. Again, I don't intend to take so much time for today because we are looking at it as our inaugural session when I'm meeting the students in this unit the first time. So we not take too long. And of course, the other issue is because I'm also still, even as I continue with us, I'm still in the middle of supervising an exam, but because I'm not at the exam place, we don't have a physical exam place, so I am able to also check through the available resources whether the students are okay with the exam. And so, so I'm still in the middle of an exam, but I think with this online, because everybody is online, we can still manage to still interact with the other students or when there is that need. All right, I think as I said, that's the much we would talk about database life cycle. But maybe I can give us a few minutes to respond. Maybe you can ask a question before I open the next topic, which will address only a few issues. We probably not want to complete the whole topic. We just address one or two issues before we close the session entirely. So any question or a point of clarification or a comment on the issues that have come up so far in my presentation and from this particular topic. So I can give a few minutes. So if you can do that, you can. I think it's more manageable if you can put your question in the chat area or a comment. You want a point of clarification, you can write a text there at the chat area, and I'll be ready to respond. So in the meantime, I don't think it's okay. The document can still remain displayed for now. Okay, so if you have a question, then you can just do a text there at the chat area, and I'll be ready to respond. But just a few minutes, like 5, and then we move on to the other topic. Yes, no questions so far. So should we just go ahead and get to our next topic, which is closely related. Now, these topics are quite closely related because they are looking at the process of developing a database and that whole process of getting, first of all, doing the requirements gathering and moving to the analysis of the data that you have. Of course, this is not about the actual data. It's about what you want to be represented in the database. So it's say, for example, I want the database to capture student names. I want the database to capture the program that the student is doing. I want the database to capture the units the student is doing, or the units that the student have done so far. I want the database to capture and show, of course, capture and show. We also bring the output, create a report. I want the database to be able to create a report for me. When I say I want the names or at least the names of the students, they can create that report. And I'm sure you are familiar with this concept of reports now. Having done some exercises in Microsoft Access and maybe other software that we have been able to use, but I know most of the time we use Microsoft Access when we are learning the basics of databases. Microsoft access. We talk about the reports. Can your database create a report on something? So you were talking about such things. I would like it to be able to create a report. I would like it to do, maybe show me, maybe do a grading or capture the grades of a student. Maybe it should capture marks of the students in a certain unit and do the grading in terms of maybe say whether it is an A, is a B, is a C, depending on the system that the particular institution is using. All these. So that's what you are, when you talk about requirements gathering here. We're not saying the actual data. We're saying the types. It's like the types of data. So what types of data and other components that do we want stored in the database? Maybe when did a student graduate? We want a database that can tell us when a certain student graduated, and say, now I want a list of all the students that graduated in 2021. Of course, now that's in the future, but we say beyond 2021, somebody might come later and say, now show me, I want to see which students graduated in 2021. And so if that is important, then that's what we're saying. We want that to be a database. The database should be able to bring out that list. So how do we design the database so that can actually happen? So when you talk about requirements gathering at this point, we're not saying about the actual data. We're not saying that it's somebody called John. No, we're saying now the name. It captures the name. So when we have put the name of somebody called John, then we can see it later. We can create what we call a report and see the name John. So that's where we are. Requirements gathering. You do the analysis and then we're also saying you then do the design of your database ready now to implement it at the computer. Okay, so I think we can go ahead and look at the other topic quickly. As I said, we're not clear to do all that, the whole of it, just pick just a few issues, and then we can finalize in our other session that we are going to create as a point. All right. So let me remove this document from the share, and I am going to load another one. All right, so I'm going to share the document. The other topic that we want to look at briefly for now. We will not complete this one today. All right, so I'm trying to share it. So I hope it will load in a short while. I think our access is good, very good. This time is quick. And so I expect it to load a short while. There it is. So let me have again a confirmation that the document is displaying well on your end. I've just loaded it. I'm going to expand it to a zoom here. Yes, is it showing there? All right, yes, so thank you so much. I can see some confirmations from Hannah and Rioba Mudini. Thank you so much. So we can have it, we zoom it, so it's the text slightly bigger. I think that should give us some good view. All right, so we are revisiting these concept of data modeling, but this time we want to go to the practicals of the same. Data modeling, which, as I said, you already did discuss with Mr. Chege. So data modeling, but here we're saying with entity relationship diagrams. I think this should be a plural. Diagrams, or ERD, or it can also be just singular. It still makes sense, yeah. But here we're saying we'll use the crow's-foot notation. So how do you develop an ERD? Now, the ERD, as we say, it starts with at the conceptual modeling. So when you do the analysis, you get the data that needs to be represented in the database. So you do first of all, you do the analysis of that data so that you can describe the data in such a way that it is possible to actually represent it in a database management system. So it says there that a number of data modeling techniques are being used today. Data modeling is the analysis of data objects and their relationships to other data objects. Data modeling is often the first step in database design and object-oriented programming, as the designers first create a conceptual model of how data items relate to each other. Data modeling involves a progression from conceptual model to logical model to physical schema. And so when you continue, when you do the data modeling, it actually takes a number of phases, so to speak, but more specifically those, we can call them, 3 phases within the modeling process, which is actually part of the design time. You see now, when we come to database, what we in Sdlc we call the design. Now when we focus on database, now we talk about these things, because now this is the design time when we are now doing the data modeling, and we are saying it progresses from the conceptual model to logical model to physical schema. In terms of the Sdlc, all these activities are happening within the same phase called the design phase. But now we are saying database design. So database design takes three kind of approaches or 3 activities that have to be done. We do the conceptual model, we do the logical model, we do the physical schema, and all that is database design. Now, one of the most common data modeling technique is the entity relationship modeling, which was developed for database and designed by somebody called Peter Chen and published in 1976. An entity relationship modeling uses the ERD, or the entity relationship diagram, to model the database structure. So there are different ways of doing these diagrams, but so we think that we are choosing this one called the crow-foot notation. So several ERD notations are available for the purposes of this unit, which is of course the other. I just picked one of the group. We will be using crow's-foot notation to draw the ERD. The name is borrowed from the symbol shown below, which will be explained later in the document. Notice how the left end resembles the foot of a crow. Now, crow, of course, is a bird, so we can just talk about in a bird anyway. Well, maybe there are some birds. I have not studied about the birds so well, so I think this sometimes it might require to be specific. That some birds, of course, their foot look like this, where it has 3, these 3. I don't know what to call them. They're coming to meet at some point here. Of course, they don't have these ones, so it's just hard just to describe something, a concept. So this when we represent and of course this line normally it is what comes at what we call a relationship. When you draw the diagram, to show the relationship between the objects in a database, you draw a line. Now, of course, I'm sure you are probably familiar with some of these things. Unfortunately, I'm not very good at these systems that I'm using here. And so I can't try to draw here. But anyway, we'll do it in a short while. But when you draw the diagram, because what you do, you have what we call the entities. The entities, you see, we talk about entity relationship diagram. So the entities are the items that you are trying to relate your data. So if you say, I want this database to capture the names of students. So that's a student. So you're, in other words, there is a student item that is stored in the database. You also say, I want it also to capture the program that the student is doing. So the program, it becomes another entity. So there is a student and there is a program. Now, how do those two relate? What is a relationship? And we'll be talking about that. But some of these already, I'm sure you already have an idea about the concept of the relationship between the data items that you want the database to capture. So when you do the relationship, so the entities are drawn as boxes, or we can call them rectangles. You do a rectangle and another rectangle. Each rectangle is representing a data item that you want to be stored in the database. Then you draw a line between the two. If they are only two, you draw a line between the two, and that is meant to show the relationship. But you also put some details that actually describe the relationship. It's not just a line. That line is supposed also to have some symbols that explain the type of relationship. And in a short while, I say something about that. And so that's a ERD. So we use this cross notation, cross foot. Actually, it should not be cross. It should just be the word crow foot. I think that was a mistake here. It should be crow foot notation. So it's just borrowed from the concept of the foot of a crow, which is a bird. And then but of course, as I said, or as it sounds, there are other ways of showing this information maybe in an ERD. There are other ways of drawing an ERD, but we are going to adopt the way of drawing an ERD. But when it comes to the relationship, we use the crowfoot notation. Okay, so what is all this about the ERD? So the data modeling process using ERD takes 3 approaches. So we have, as we say, there are 3 activities. It is a process of data modeling. So the 3 levels of data modeling process. One is a conceptual model, develop what we can call an initial ERD, because it's an ERD, but it still has more work to be done on it. With this ERD that we created, what we are calling a conceptual model, or to create the conceptual model, here the main thing is to look at the data that you have agreed at gathering or requirement gathering. Look at that data, analyze it, and out of that, see what are going to be the entities. Which entities will be represented or are coming out of this data? What are the entities? And that is our main focus at the conceptual model level. The entities and their relationships. That's what we focus on. Let's identify the entities and also their relationships. So that is the conceptual model level. But we go to the next level, we do the logical model of we reach at the logical modeling of the data. And the logical model, when we create an ERD and the logical model, we describe attributes Of course, we now decide to do something called now the attributes. Attributes are supposed to be the properties of an entity, the attributes of an entity. So now we need now to go deeper and now analyze the entities that we identified in the conceptual model. What would be their attributes? What are the properties? Because you see, when you represent an item in the database, you actually have what are the attributes of that entity. And the attributes are actually what you store. The attributes are what you store in the database. So what are the attributes? The properties. So for example, if it's a student, what data do you want to be stored about a student? That is what are the attributes. What data do you want to be stored about a student? And of course, we can think about a few things that would like to store about a student. And I think we're going to pause there, and I want you to suggest me what are the type of data that would you consider that needs to be stored about a student. And some of them we have already mentioned, but let's go. I want us to interact just slightly, just a few minutes. Again, I'm going to allow only about 5 minutes. I want you to do it in the chat area. What type of data would you like to be stored in the database? Yes, so just do another chat kidogo. Let's do some chat there. I can see Mark has started by saying, Mark, what else should we capture about a student? Now, a student is now an entity in our that we want to go. We're going to have in our database a student. But what details do we want to store about the student? Yes, let me see more. So Marks from Dairo, name from Mudini, attendance from Mark again there. Mindget says also name, ID number. Those are two items, yes. Jacqueline says fee balance, registration number, yes. Fee status, yes. You can say how much has the student paid, maybe in percentages, maybe 50% paid, 6%, yes. Rioba reminds us, yes, we also need to say, is this a male student? So we have of course, these are finally, we talk about the column. There is a column for sex. There is a registration number, yes, by Malemo there. Levi says a fees payment. Rioba says again a male or female. Sorry, Rioba, you said male or female, but I think you meant male or female. Then there is a senior says the year of the registration. Yes, very key. She says the date of registration also. On the Karani disability status. Yes, those are important concepts. Yes. Only date of birth, wonderful. BOD, normally, DOB, we sort of say DOB in short. Yeah, that's very good. Thank you so much. Keep adding more. If you have not added, even if I've moved on, keep adding. But yes, email address. You can notice there are so many items that we would want to capture about a student, and now those are the attributes. We normally just summarize it as properties. The property attributes are the properties of an entity. An entity is the item that we want to talk about in the database. In this case, we're saying a student. So we want to talk about the student in the database. But what details about the student? Those becomes the attributes. They become the property. So attributes are properties of an entity. So notice therefore, thank you. Rioba has also added the phone number. Yes, so depending on how detailed we want, and of course, the more details, the better. The more details, the better that that database can help. Of course, we have not exhausted the list, but that's very, very helpful to guide us. And so we're saying that at the conceptual level, we mainly focus on entities, identifying entities, and of course, relationships in the entities. When we go to the logical level of modeling, now we want to identify the attributes of the entities, and then we also do a process called normalization of the entities. We'll talk about this one probably in our next session, next class, normalizing the entities. Then we also identify, now these ones are familiar concepts, identify the primary key and the secondary key. So we do all these around the logical modeling. I mean the logical model level of data modeling. And we redo our ERD now with that more detailed ERD. So as we have a simple ERD at the conceptual level, we do a more detailed ERD at the logical model. And then finally, we go to the physical model level of the data modeling, where now we come up with the, of course, yeah, we don't really do another ERD, but now we try out to use the ERD to guide us to do now the physical modeling, where we suggest a number of other things. Most of these may not be represented in a diagram. Actually, when we come to the physical model, we don't have the actual that we don't have a diagram. We still rely on the logical model, but we translate the logical model now to what we are now calling the physical model, where we now decide on the actual storage. What do we need to do to do the actual storage for our database? And that takes us to the physical model level of data modeling, especially based on a certain DBMS or the DBMS type or database model. And of course, currently, most of the database that we have are based on the what is called the relational model. So we base now our logical model on a relational model and decide now exactly how is our database going to look like, how many tables. Of course, that is likely to still come from the logical model. How many tables and what will we call these tables? What are the now the attributes now become the columns or fields in an actual database table. So we say now these are going to be the names of our columns in the database. We also decide a couple of other things that cannot be described in the diagram. So of course we can still put them in the within the ERD at the logical level. Some of these details can be put there, including identifying which are the primary keys, which are going to be the foreign keys, what are the data types. Is another very important thing. Data types at each column. Each column, what is going to be the data type at that column. And so those are the details that we'll be doing at the physical model level of data modeling. Now, what I want us to do now is just to have an example of a simple data modeling. So I'm going to take us back to, not back, but we'll go to the whiteboard and just draw for us a simple ERD. So at the conceptual level, you just keep at the conceptual level. Next, in the next class, we'll go to the other two, logical model and physical model. So ERD at the conceptual model level of data modeling. So we go to the whiteboard and we look at an example, just a simple example. Let's assume that it's still based on an educational institutions, things that happen in educational institutions. The objects, the type of items that we get are there, educational institution. So I'm going to remove the share of the document, and I take us to the whiteboard. So at the whiteboard here, we say that entities, now you see when you're doing the requirements gathering, you just say things without this time being too keen on what they represent, how they will be represented in your database. So that just like we have been doing here, for example, you might say when you are doing the requirements gathering, maybe there is this system analyst, he or she visits an institution and says, now you called me that you want to develop a database. Now I'll come now so that we can discuss. So what type of data would you like this database to capture? And then you start the data requirements gathering. And they talk about all those things. You know, they talk about the student. So they say the student. Sometimes they may just go ahead and just say, okay, details about the student. So the student is going to be put in the database, but details include just those things that we said alone. So what is the agenda? So these people at the institution will tell you this type of words. So we wanted to capture gender, marks. We wanted to capture date of birth, DOB, registration, when is this student register at institution. So this is the date. So these are about the date. Sorry, sometimes making some mistake there, but we understand. So date of registration. I also want to know registration number, of course. So this student will have a registration number. It should capture that, etc. So then we put as many. Of course, there is a data requirements gathering. So the many data items will be mentioned. But maybe also there will be somebody might say, oh, if possible, this system should be able to create a timetable. So the timetable, so there is a timetable. And then again, so the timetable, so what type, some of the things that relate to the timetable, of course, is the units that are being done in a certain day. Probably also time. Normally for going to a class, there is a time. And many other things might be captured there, maybe the unit name, and also maybe who is the lecturer teaching that unit. So as many details that relate to a timetable, you see. Then you talk about things like the program the student is doing. So that's that should have come up at the other part there. But don't mind that these things that happen like these. Somebody may not have remembered everything when you are listening about the student. Then later on, as you continue, of course, it's not going to be a 1 hour discussion. It's not even going to be a day. You have a meeting a certain day, then you close that day, and you come, you meet again. You continue to meet severally until both the analysts and the organization feel that we have exhausted the major things, and so now maybe you can move to the next phase. And now you go to the next phase and you do the analysis. So now much of the work is left now to the analysts to analyze these data items and decide, now start to do the modeling. Try to model now these data into something that can be represented in a database electronically in the computer. So from the data gathering, you go to but here, for the sake of this example, I think let's add the lecturer. So lecturer also, who is actually a member of staff at the institution, if it's an educational institution. So we also need to have some details about the lecturer stored in the database. So maybe which department is this lecturer in? Of course, the name. And by the way, I left the name for the student, of course, should be named. Those are some of the very basic items that will be there. Probably date of employment for lecturer. I'm not going to complete everything here because of time. So then maybe something else might be maybe the units. Or maybe we can say the department where it can be because of the timetable. We need which units lecturer is teaching at a certain time. That could just be borrowed from the timetable. Maybe, of course, other details that will be captured, but which are more relevant to the relationship between a student and the lecturer. So if you capture all these, of course, are going to be captured in our database later. But now we are at the level of requirements gathering. Then we move now to the next phase, which is analysis, where we now develop the conceptual model of the database. We go to the conceptual level or the conceptual model, which our main aim is to decide out of all these items, which of these are going to be entities. Now, entities, you focus on those which are nouns. The words that are nouns are the ones which are developed into entities. The words that are, and of course, not all of them, but usually, then when you are trying to identify the entities, we'll focus on the words that are there, which are more of nouns. They should be nouns, but some of the nouns cannot be entities. Some of the nouns will be attributes. But again, when it comes to attributes, we focus on the most of the time. Attributes are developed from the words that are adjectives. They describe the noun. You remember adjectives? Adjectives that describe the noun. So the words that are adjectives build most of the time into the attributes. But first of all, is to identify the entities. One of the key challenging part is identifying the entities, which is very important because actually entities will help you design your database. So which of these would be best to take as the entities? But remember, some of those that are nouns actually finally cannot stand on their own. They will need to be part of an entity. All right, so because of time, let me just go ahead and say that obviously student will be an entity, lecturer is an entity. Now, normally we say that an entity is anything for whose data can be stored in the database. An entity is anything whose data can be stored in a database. That becomes that's how we describe an entity. Anything whose data can be stored. So in other words, you'll be thinking, which of these can we have some details of it being stored in the database? Is there anything is a person or thing whose data can be stored in the database? So student, of course, yes, we can store data about a student. So student would be an entity. Just of course we don't, because again I'm also checking on time, entities. So some of those entities in this case that we can talk about when it comes to an educational institution would be something like student. We can store data about a student. We can store data about a lecturer. We can store data about a unit. So these are some possible entities. We can store data about a program. Obviously, we can store data about a department. Okay, etc. So all these are possible entities. But as I said, once during the analysis, you might find that some of these will not really be entities in the database, although they are entities by description, the way they look like. But when it comes to the actual designing of the database, you might find that some of these would only be act as attributes of another entity. But now, for now, if you can say, okay, those are some of the entities that are possible, then now you go to draw your conceptual model. So when you do you draw your conceptual model, we say that the entities are represented using rectangles. So for this time, we are not identifying the attributes, we are only identifying just the entities. So in this case, for now, I'll talk about the entity of student and lecturer. So let's say one is representing, and normally at this level, we use a singular to represent entities, use singular. So we talk about student, not students, and lecturer, not lecturers. So for at this point, we use singular. So if we just label them for the sake of some clarity here. Now, actually, I should expand this and make it a bigger screen. So lecturer, maybe you can make that bigger. And student. So these are two entities. Of course, there will be, by the time you complete by the time you complete your design, in most cases you are likely to have very many entities. But for now, we're just using this one for demonstration. There will be very many entities. Maybe for the sake of again of just having some more variety, we can add another one. Sorry, my space is small, but let me use this space here. Now that now this one, I'm going to make it not as big. Or let's reduce. All right, so let's just use a small rectangle here to add for program. Suppose we add program also. It's a possible entity, but it's because of the space, I'm going to make it small here. Sorry for that. Now, I think it changed my color. So let me go back to, right, sorry. So let me redo that. They cannot be black now. Sorry, I think I'm missing something there. I don't want to, yeah, I forgot to select the rectangle tool. Okay, so we have one, so let's have 3 boxes. for student. And lecture. And then we also have for program. There is a program is likely to be an entity in our database. So once we have designed our, or we have identified our entities, we also need to show the relationship among these entities. Remember, these is a diagram that is a part of the designing of your database, but these all are drawings. It is not, of course, you can draw at the computer, you can do it on paper, but of course, it's best if you can actually be able to draw it. And of course, we also have softwares that can help us to do the drawings and draw them very well. In fact, once you identify your various items, there are some softwares that can actually create the diagram for you. All right, so you need now to show the relationship. So the relationship, we say it is a line. That's why we are talking about a crow foot. So in our case, we are using the crow foot to show our entities and their relationship. So in the crow foot, you draw a line between the entities. Of course, you can have all of them related, but for now, let's first of all not show a relationship. No, of course there should be. Fine, I think this if it's about student and programs, obviously there will be. Now, of course, you notice that this one is not a straight line because I'm trying to also put it in a way that is clear. It can actually do an angle like that. It's all right. But now you have to show the type, the relationship type. So you don't just draw a line. There must be you put some details on these the relationship lines. You need to put some details that indicates what type of relationship are these ones having, or how do you describe the relationship there? I want to believe that this is not the first time that you are hearing about these concepts about relationships. So we say that relationships are types of relationships. So just reminding us, I hope these are a reminder. So the types of relationships. So relationship types. I think this was also captured in the previous class with Mr. Simon. So the types of relationship is what? 1 to 1. 1. Full colons means 2. 1 to 1, 1 to many. And normally it's put as a capital M. And 1, and of course many to many. Sometimes is put M to M, but I think the more the correct one is to say N to M. All right, so 1 to 1, 1 to many, and many to many. So you need to show that at your lines that are indicating the relationships. And it's a very simple process. Normally you read both directions. So read both directions. So first of all, read left to right, and then you read left to right. And what you ask yourself is, one student, how many lecturers can he or she have? One student in an institution. Is it so? Then you put it on the other side. Once you identify how many lecturers a student should have, then you put it on the side of the lecturer. So if you are looking at left to right, then your relationship symbol for that process will be done on the right. And so we say one student obviously can have several lecturers because you are being taught several units, and each of these units may be taught by a different lecturer. So one student can have many lecturers. So with cross-foot notation, we indicate that by doing, so let me get the right tool here. By doing the crowfoot, the structure of the crowfoot is indicating the many. So one student can have many lecturers. And then you read it the other direction as well. And you ask yourself, one lecturer, how many students can one lecturer have? One lecturer obviously can have many students, even in one, just a single unit. A lecturer can have many students. All right, and therefore, this is a many-to-many relationship. So this line now, as it is indicating many-to-many relationship. So a relationship between a student, and of course, this is going to be important in the database. So that's why we are doing this, because it will guide us when actually creating the database. Now let's do the final one because of time. So suppose we try this one of student and programs. Now a program in this case is like you are doing SIT, you are doing a DBIT, or DBIT, DSES. Those are the programs. Okay, in this case, in this respect, we are looking at the word program from that respect. You are doing a DSES, you are doing DIT, you are doing DBIT. So what is your program? What is your program? So when we come to that and we're asking ourselves again, so we say one student. So remember, we always do it both directions. So go the left, right to left, no, left to right way. So one student. So remember, the direction that you are moving on, you first of all say one. So one student, how many programs can the student do? And of course, here again, we are saying at the same time. And again, we use the most logical way it happens. So one student, ordinarily, one student does one program at a time. Of course, you can do this years now, then later on decide, no, let me also do maybe human resource, and then another time let me, so especially in an institution, the institution may not, it may not be practical that you are doing more than one program at a time. So ordinarily, therefore, one student does one program or has one program, one at a time. So the relationship shown, what you say about the programs, then you put that on the side of the programs here, because you are reading it from left to right. So the symbol should come to the right. And so one. So how do we show one in cross-foot notation? Is simply a vertical short bar. So a vertical short bar indicates one. Okay, one student does one program. Then you read it the other way around, of course. Okay, now you say, now, one program. How many students can do one program? Or one program, how many students does it have? All right, one program, how many students does it have? And it is many. So we put many, the symbol for many. And so this is a one to many. Now, of course, when there is a one and many, we normally start by the one. So it is one to many. Of course, you can say many to one, but we normally say one to many. So for a student, the relationship between student and program is one to many. It is a one to M, one to M. For the students and the lecturer, it is a many to many. Many to many, it's a M. But as we said, you can also do it as NM. N meaning from the word number. N is normally used a lot symbolically to represent numbers or as a number quantity. So, but you are free to use any of these methods of representing many to many. I think M to M might be easier for most people to remember. And so, of course, you need to also do this one. So lecturer to programs. So of course, you say again, one lecturer, how many programs? Of course, in this case, now remember actually, something that I left out is that a relationship normally has a name. Of course, it's it's you who decides the name. There isn't a unique name. It's the designer or the system analyst is the one who has gone, whoever is doing the designing is the one who decides what name to give to the relationship. So like this one of lecture, you can say, since you normally read it, you can read it both directions, but normally left to right, and call this relationship taught by. Because of course, should make a logical meaning when it is a student taught by a lecturer. And this one would call it student enrolled in a program. So you can see call this one. This relationship can be called enrolled in. So a student is enrolled in a program, and those would be the names. So and then we can say the taught by relationship is many to many, and then sorry, I forgot in it should have been complete for it to be logically read properly. Is enrolled in. So it's enrolled in a program. So the enrolled in program is a one to many. It's a one to many relationship. Okay, so I think that is sufficient for today. Unless there is a question, so any question as far as whatever. Now, notice that I will not complete the lecturer versus program relationship there, which we need to also describe. Is it a one-to-one, one to many, many to many? But for now, I think we'll keep it at that. Any question related to what we have said so far? Any part of our discussion, probably especially this the last one. Any question? Because I want to bring our presentation to a close. So I think we have had quite some length of time going almost how much? Beyond 1.5 hours already, which is good, but we still take it. We will not go the full extent of the time because I'm still supervising an exam online. But as I said, it's possible that I can keep on requesting you to give me a few minutes. I check on the exam and I can continue. And I think we have done well this far. So any question, any comment related to our discussion, what Mwalimu has brought to us. Yes, the notes will be sent in a short while, actually, within the next 10 minutes of ending Mwalimu's presentation. I will post my 2 documents are there. One is at topic 4. Actually, I'll post them together because we have covered them together. So they will appear at the same space within the portal as topic 4 and topic 5 notes. The topics will be topic 4 and topic 5 together, so that the notes can show together. It will be easier locating the notes that way. Yes, so the notes will be posted. Yes, and the notes will be posted within the next few minutes. As soon as the Mwalimu is over with the presentation, the notes will be posted there and you can access them. Except, of course, remember this diagram we are just drawing as an example during our discussion. You will not see this diagram there, but of course, we have recorded this presentation, so you should be able to see this diagram when you open the video. After about half an hour, I think it takes a while before it shows the portal, so you'll be able to see this diagram there. And maybe for that reason, I think it's good. Maybe I should put some details on about this diagram so that when you go there, it will make sense. So it's all right. Yes, so allow me to add some description of what is going on here. So we are saying that first of all is that relationships should be named. Should be given a name. And the type of relationship should also, the type of relationship is showing symbolically. Is indicated on the relationship line. Using symbols. So we don't indicate whether they are one or one to many at the relationship line. You indicate using symbols, but the symbols are showing that taught by is one, is a many to many. While enrolled in is a one to many. It's a one to many relationship. Okay, so one to the enrolled in relationship is a one to many. They say that one program can have many students, but usually one student does one program at a time. So it's at one particular moment, it will be a one to many. But of course, the student can keep doing other programs with the time. You finish one, do another one, do another one at one specific time. Now, remember again, these issues will take the way they happen in a real life. It's not something that you have to calculate. All you need is to decide in a real life what happens. So it's just like saying now, suppose you had you said a car and its driver. No, that is not a very clear one. I think the one which would be very obvious is parents and children. So if we had a parent entity and a children entity. In a real life, we say that one parent, in a real life, of course, ordinarily, would say one parent can have many children. So parent to children. Of course, maybe here we need to be more specific and say it's of course you have now to think one by one, not both parents, but one parent at a time. So one father can have many children, but what about one child can have now biologically? So he's saying you have to think of these the way it is normally in a real life. The more weighty it happens in a real life is that one child, if you say that's a relationship called belongs, then one child belongs to one father or something like that. But what I'm trying to emphasize is that when you are deciding these things, it's not something that you try to look for a theory. No. It's something that you have to think of them, how they happen in a real life, or the practice that is normally associated with that type of a scenery or an environment, etc. So just like we'd say, if there is a country, and you say one country, how many presidents does a country have? Of course, you say one. So country to president is one. The other side is a one. Or if you read it the other way around and say, so one president, how many countries is that president a president for? And again, should be one. So that in ordinary situation, it is a one-to-one. So these relationships are supposed to be described as things happen in a real life. So some intelligence there will therefore be called upon. You are experiencing how these things happen. What information do you have? Those will be important in describing the relationships. It is not a theory issue. It is things as they happen in a real life. Of course, you may need some theory to understand certain concepts of how things happen, but remember you describe these things as they happen in real life. Yes, any other comment, question, or clarification? Now, the assignment 1 of this unit is already at the portal. Please check now. This is what I'll be doing. When it comes to evaluations, cards, and assignments, which are meant for grading, as a quiz, something that will be marked and graded for the unit in terms of coursework. Those ones I'll put them at the space normally just above where topic 1, the line of topic 1 shows. So they will be appearing above that line. So assignment 1, cut 1, etc., will be showing there. And so that's where you'll be checking that there is an assignment. Already this assignment 1 is posted. You need to do it within a week. I think from today. I think it starts counting from today. So make sure that you do that assignment 1. And it's also going to be done online. Just check there and go visit and see what type of questions are there, and do that assignment 1. But there are also these activities that we do as part of the class. So unfortunately, I wanted us to have a quiz activity. It is not complete. So I'll allow you some time. So visit later on and also check. So of course, the activities for the class should show at the same space that you get other details about a certain class time. So of course, they say this is under topic 4 and topic 5. They will be put in the same area because that's how we have done them. So topic 4 and topic 5. You'll see the activity for that particular space. Of course, I've put only one activity, and it is going to be a quiz. So make sure that so it will not I'll not ask you to do it right now because it's not complete. but visit later and check the quiz or the quiz for this particular class. But remember, there is already assignment 1 posted, and you should also make sure that you attend to that and complete it. That, of course, is specifically for grading. But remember, even these activities are for grading, but these ones are done automatically by the system. In terms of your participation is very important. Of course, make sure that every activity, including the attendance of class, you must have those activities. They are graded automatically by the system, and so it's very important that you attend to all the activities that have been described. All right. So, any further comments, question? All right. So I think then that will be sufficient for the lecturer's presentation for today. Thank you so much. So as I said, within the next, within about half an hour, you can revisit the site, and you should be able to see the video should have been completed by then, and you can do a review of some of the things that we have said and which you want to revisit. So I think for that should be possible. As I said, also within a few minutes after Mwalimu's presentation is over, I will post these documents that we have been using for a discussion. But I was also pointing out that this particular diagram is not in the notes, so you will only see it from the video. And I think I've just remembered that I need also to caution us that the student should fill in the relationship for lecturer to programs. That one has not been done. So student should fill in. So that's too big. Student should fill in the relationship for lecture program. Sorry, let me lecturer. Lecture to program. Oh, my box is too small. It's not completing that part. Right. But anyway, you know what I meant there. But anyway, let's I think let's do it. Anyway. Sorry. Anyway, so students should fill in there. Relationship for lecture to program. Sorry, I have misspelled. It's missing some words here. Program to lecturer. in our previous diagram there, just a reminder that that one is not yet completed. It needs to be completed. You need to do the symbols for that one as well. All right. So otherwise, I think that's sufficient for today from Mwalimu. So let's see how we catch up. I think next week we'll look at the possibilities of a number of makeups. So we can catch up with the syllabus. We are quite far behind. I missed at least 3 sessions, mainly because of the weeks of the exam. So we'll need to catch up. We'll look for possibilities of another a few makeups, at least 2 of them. That will be very helpful. So for now, thank you so much for attending today's presentation. I wish you the very best in the remaining hours of this morning and the rest of the afternoon. So for me is kwaheri, goodbye, enjoy the rest of the day.